Hi, what is the value of k? Given that you have k to the power of 2 minus k to the power of 3 equals 12. So let's have it to the solution. From here, we have k to the power of 2 minus k to the power of 3 equals 12. From here, we have k to the power of 2 minus k to the power of 3. Let's take this 12 to the other side, it will be minus 12. Then let's set everything to be equal 0. We have k to the power of 2 minus k to the power of 3. Let's have this as minus 4 minus 8. Minus 4 minus 8 will give us minus 12. Then we set everything to be equal 0. Then let's have 4 and 8 in base 2 as, let's write this first as k to the power of 2 minus k to the power of 3. Here will be 2 to the power of 2 will give us 4. And 2 to the power of 3 will give us 8. So we set everything to be equal 0. So we have this and this to be in base 2. Then you can see we have power 3. This one has power 3. Let's group them together. This one has power 2. This one has power 2. Let's group them together. So we are going to have here to be k squared minus 2 to the power of 2 as this. Then we have here to be minus k to the power of 3 minus 2 to the power of 3. Then we have everything to be equal 0. Then from here, let's have it as open bracket k to the power of 2 minus 2 to the power of 2. We close it. When we factor minus outside here, then we open bracket. Minus divided by minus, here will be plus k to the power of 3. Here will also be plus 2 to the power of 3. Then we close it. We also set it to be equals 0. Then remember, this difference of 2 square, that when you have a square minus b square, this always equals as a plus b, all in brackets, again multiplied by a minus b, all in bracket. Again, when you also have a to the power of 3 plus b to the power of 3 equals, open bracket, a plus b, we close the bracket, again multiplied by a square minus a b plus b square. So having known that, let us apply this here. Let us apply this one here. We are going to have this to be k plus 2, then multiply by k minus 2. For this one, here will be minus. Then here will be k plus 2 as this. Here will be k squared. But here will be, our a is k, our b is 2. Have minus 2k, b squared is 2 squared will be plus 4. Then we have everything to be equal 0. Then from here, we can see that we have k plus 2 in common. So we have here to be k plus 2 by factoring it out. So we open another bracket. The whole of everything here divided by k plus 2, we only have k minus 2. Mind you that the whole of everything here divided by k plus 2 all in bracket. Remember we have minus here. We only have this left, open bracket, k squared minus 2k plus 4. Then we close it. Then we also set everything to be equal 0. From here, we have k plus 2 as this. Then from here, we have k minus 2. When you open the bracket with minus, definitely here will be minus k squared. Minus times minus here will be plus 2k. Minus times plus here will be minus 4. We close it. Then we set everything to be equal 0. From here we have k plus 2 all in bracket. From here, let's rearrange this as minus k squared. K plus 2k, we have it to be plus 3k. Minus 2 minus 4 will give us minus 6. Then we close it. We set everything to be equal 0. Then from here, what are we trying to say is that for this expression to be equal 0, is either we have k plus 2 equals 0, or we have minus k squared plus 3k minus 6 to be equal 0. Then from here we have k to be equals minus 2 as our first real solution. Then from here is negative, so we want to make sure that the power 2 is positive. When we multiply 2 by minus, minus times minus here will be k squared, here will be minus 3k, here will be plus 6, then we have everything to be equal 0. Then from here, we can use the quadratic formula as we are going to have k to be equals minus b, positive or negative, square root of b squared minus 4ac, all divided by 2a. Then from here, our parameter a is the coefficient of k squared, which is 1, while our b is the coefficient of k, which is minus 3, while our c is the constant, which equals 6. Then when we substitute everything here, we are going to have k to be equals minus, already here will be 3, positive or negative, minus 3, all in bracket to the power of 2, minus 4 into a is 1, c is 6, then divided by 2 times 1. So we are going to have k to be equals 3, positive or negative, square root of this one, we have 9, minus 4 times 1 is 4, times 6 will be 24, then divided by 2. So from here we have k to be equals 3, positive or negative, 9 minus 24, we have it to be minus 15, square root of minus 15 divided by 2. And this can be simplified as 3, positive or negative, root of 15 multiplied by root of minus 1 divided by 2. So we have k to be equals 3, positive or negative, root of 15, root of minus 1 will give you I. Then divided by 2. So from here, we also have another value of k to be equals, the already one is minus 2. That's, you can say k1. We also have another k2 to be equals 3. When we go with plus root of 15i divided by 2, we also go with k3. It will be 3 minus root of 15i divided by 2. So we have this to be 3 answers. Why k1 is the real solution, the other one is the complex solution. So if you are new here and find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more maths tutorial videos. So if you want to check for the real solution, we have k to the power of 2 minus k to the power of 3 that equals 12. When we have the first real solution as minus 2, let's see what will happen. Then here will be minus 2, all in parentheses, to the power of 2, minus outside, open bracket, minus 2, close the brackets, to the power of 3. Then are they going to give me 12? So minus to the power of even will give us positive. So here will be 4. Then here will be minus, here will be minus 8. Then is it going to give us 12? Here will be 4. Minus times minus will be plus 8, which equals 12. So from here, 12 equals 12. Bye-bye.